Okay, we are recording. Okay, we were discussing social media issues. We had an agenda to talk about distributed DNS first, but we're going to wait for the principals to arrive in their offices to have that conversation. So we'll continue our conversation with social media about distributed social media. I did have something planned for that, and what I'm going to try and do here is take myself off the screen and bring up Notepad. All right. Can you see my screen?
Yes.
Great.
Yes.
Wonderful. Okay. So I thought I presume everyone's read my little 5-minute sort of introduction to concepts and requirements for a distributed social media platform. And the reason why I did that is because I think some people are getting it wrong right out of the gates. They don't really understand what decentralization is. So I thought I would break it down into a system of 7 somewhat simple requirements and as a starting point. And I thought maybe I would just go through these points here now and discuss them and see what else comes out of that conversation. So the first one is have distributed servers. The physical disposition of the servers must be distributed across a network so that they cannot be controlled by a single entity. And so, definition of terms comes up. What is a server in this context, for instance? It's possible that the blockchain nodes might serve the purpose of a relay similar to the nostr protocol. If people have been following that discussion about nostr, there's been plenty of information posted on it now. I posted a little segment of it in my architecture notes. And we need to identify and define subsystems in this architecture. So yeah, X482, for instance, has 2 or 3 subsystems within that architecture, right? They have 2 different types of servers, for instance.
Yeah. Are you referring to the different tiers of servers?
Yeah, you have. I don't exactly remember the details, but yeah, I knew there are different types of servers. So you have tiers of servers that serve different functions or have different capacities, different roles.
Yeah, that's correct. So basically we have 3 tiers of servers. And with that, each tier performs specific functions on the network.
Okay, right. Okay, so in the social, and frankly, at least for my personal implementation, wonderful thing about Blockcore is that it's a test bed. It's an open platform of ideas to try stuff out. But I am very, very interested in trying to use X42 to come up with some kind of social media platform. Because the fact that I can host, the client in a distributed fashion, the client being the actual social media app, and have a distributed, worldwide. But I want to try and understand that when you say you're hosting, you can host anything that can be hosted in Docker. Docker can be hosted on the server. Obviously, we're talking about the nodes themselves, the blockchain nodes.
That's correct.
Okay.
That's correct. Yeah.
Okay. So in the sense of the social media platform, then I would see them hosting the work of this social media platform, and the work that I see needed is essentially proof of identity. And if you're following the KERI, the KERI, the KERI conversation, there's a KERI protocol out, and there's a CSR protocol out that's part of it. We're dealing with proof of identity, proof of attribution, which is who said what, and being able to prove it. And then proof of veracity, is it true? So this is actually work that can be proved. And I'm thinking about essentially modifying a proof of work consensus algorithm to do this meaningful work instead of trying to solve a mathematical puzzle, which is meaningless work. So, so anyway, that's some work that could be done on the nodes, but also along those lines, it could serve as a relay in the nostr sense, right? If we're following that conversation about nostr just essentially being a collection of clients and relays, and the relays are simply just shunting the messages, around the network. It's possible that these social media nodes could serve a similar purpose. So yeah, and then the clients themselves, it's still not clear in my mind where the social media client would come from. I mean, how is it served? Is it served could it be served from the social media nodes? What say you? Anybody got ideas?
Yeah, hi guys. Sorry I was late. I'm enjoying now.
Oh, you're here. Okay. Okay, Dan, just because, now that you or Sandra are online to discuss the previous week, the DNS stuff, I thought we'd just get started on this, so we could circle back to the DNS issues afterwards. Is that okay?
Yeah, absolutely.
Okay.
One of the ideas that we discussed was basically clients will be browsers. So one of the things that in the early days that we were discussing a bit of decentralizing communications with users was that actually the browser will be your browser will connect to other browsers and store, and then you will exchange information, and then you will store it locally in your browser. And let's say you create a chat group between 3 users, then the data for that chat is shared between those 3 users directly on their browsers. And then if one day you connect from another browser, you connect to that same group, you would just sync the data from the other participants. So the data for that chat or that group will always just be saved within those participants of that group. To answer your question about where.
Well, okay, so that's fine. That sounds very similar to the the nostr protocol. All right, so that's fine. I want to explore that, and this is being recorded, by the way, Dan. In case you came in too late to notice that, this is being recorded. Okay, so I don't have to take notes. I'm sorry.
Okay, yeah. Isn't nostr? Don't they have relay nodes? So
they have relays. Yeah, it's clients and relays. Yes, that's what they've got.
So that means there needs to be some nodes running hosted by you.
There needs to be something, and there's another point here. You're saying about basically the sharing of data. Well, that's the thing that I'm not envisioning very clearly either, especially if you want to try and adhere to the 7 requirements. You don't have to, of course, but one of the requirements here, which is data ownership. Each platform user must have complete control over their data. Okay, so for instance, let's give it a simple use case here. I have a niece. She has a 2-year-old daughter, and my niece posts pictures of my niece on Facebook. And honestly, it's the only reason I have a Facebook account is so I can see pictures of my nieces and nephews. That's pretty much it. Yeah. All right, but my niece, she owns those pictures in a perfect world. She has full control over the pictures that she posts, and she can control the policies controlling those pictures, which is that they age out in a week, age out in 2 weeks, whatever. They disappear from the internet forever. Nobody owns it. No one can control it except her. So if you've seen one of the ideas I had in my sprawling architecture notes pages there, I don't know if you've come across Filebase, which is an interface to like 3 or 4 different distributed file, decentralized file services like IPFS and SIA. And so they have an S3, AWS S3 interface that works exactly like S3. The way you implement it in .NET is you actually install the AWS S3 NuGet packages, but instead of putting in the endpoint addresses for AWS, you put your own distributed, a file base address in there, and then it goes into a distributed platform. The data is distributed in a decentralized platform. It doesn't actually hit AWS at all. And the interesting thing right now is that the first 5 gigabytes are free. They don't charge you for them. So I'm thinking we could come up with a system where basically if we reach that free threshold, that free data threshold, we simply roll the data over, right? We just age out the oldest data. So that's the thing. I just think thinking through how the data is handled in a decentralized way, that's go ahead.
If it can intercept your line of thought here, you don't necessarily need to store the data in a decentralized way, because if we're talking about data ownership, what you want is to control who has access to this data, not necessarily where it's stored. Imagine you have like a system where you can interact with, let's say, with your niece. You want to see, you have a chat within your family, and you want to see pictures and share pictures. The data can be stored on any cloud provider, but the keys to encrypt and view the data will only be shared within this group. So it doesn't have to be decentralized file storage. It just needs to be like who has access to this data. If you can store encrypted data on a cloud, then you can, for example, have a few backups of this data on a few different clouds, and it still be encrypted. Nobody has access to that apart from participants.
Okay.
For example, I don't know if you're aware of Sphinx Chat. So
No, I'm not.
So they have this. So this is chat. They use chat via Lightning, and that's very interesting because they use the Lightning infrastructure to relay messages between them. But then they also came up with this ability to store your data on other providers like CDNs or whatever. But the CDNs, they don't have access to the data. The data is stored and encrypted, and then to get access, you're just given a decryption key. You can fetch the data and read it. And then like only certain participants would be allowed to get this decryption key. I mean, you pay for it, and that way the data is stored and nobody has access, and then you just share the decryption keys, for example. And I think that idea is very interesting because then you don't need decentralized storage. You just need some accessible storage, and you can decide to have a few data storage sources that you can back up your data, and nobody can read it, nobody can access it.
Okay, so but who is paying for the storage?
So on Sphinx Chat, you would, for example, on Sphinx Chat, and if I remember correctly, maybe the dude can correct me if I'm wrong, but you could make a payment to the DNS, to the person who is, to this service who is storing the data, so you could make them for accessibility. So you could store it, but to access it, then you have something.
Okay, because I think one of the problems you're running into, for instance, like this is an example with your DNS problems, is that it's expensive, right? And so you're trying to find a cheaper way of implementing DNS, and that's why you're going the distributed route, the decentralized route, really.
Yeah.
So, but so I just think. one needs to think through how is the system going to support itself once it's released into the wild. And that's something I really think needs to be thought through before one starts writing code. Honestly, it's just part of the design phase where, once you deploy it, how does it run? How is it supported? Right?
Architecture
Go ahead.
From an architecture perspective, one of the things I've been looking into recently was the Cosmos SDK, and I quite liked how they came up with the Sentry nodes and like how they architected that, where you could have relays or you could hide your validators behind them so they wouldn't get disclosed. Well, could that similar principle be applied to something like X42, where you have the X server play the role of the validator, and then maybe have these Sentry nodes in front, which kind of like act as the relays or gateways, essentially, that provide these services?
Yeah, I think the cloud solves a lot of problems, and there's no reason why one cannot use the cloud and also be decentralized at the same time. Obviously, you can. The cloud does not speak to decentralization one way or the other. But it is a huge enabler of functionality. My only concern is it needs to be paid for, and so I want to ask the question up front: how is it paid for? And so
Hey, yeah,
go
I
ahead.
can give a little bit there. I'm back home here now. So the first thing is sort of the definition of server here. It's like I had some discussion on Twitter. There's a lot of people that says that we will never have a decentralized world because people won't be running their own servers.
Mm-hmm.
But I think they're thinking wrong, because a server is basically just some piece of software that serves some data, right? When I'm running OneDrive on my machine or on a Mac, you can actually configure it to not store anything in the cloud, but only use relays to serve your own data. If I take a photo on my phone, I can get it synced to my desktop PC without actually storing anything in the cloud. But you need those relays though. So that's where like nostr and X42 server and this DNS thing comes in, and it's primarily to relay sort of and find public endpoints for things. And I think in where the data will be stored, it will be stored by a regular user, either, as Dan mentioned earlier, you can just use your web browser. Your web browser can connect with WebSocket to an endpoint, and then you can use local storage in a basic web browser. Or you can install a small application where you have your photos. So in your example, you're sharing photos of your niece with someone.
Mm-hmm.
What will happen then is that person just copies that file into a folder or somewhere on their local machine or mobile device, and they set the rules on who should be able to see this content, and also maybe if they should be allowed to sync it, right? So you could have a way where you say that it can only be served from my machine. So you basically validate sort of the public private key encryption every time the image is requested, right? So you could at any time just withdraw access to that photo, or you could allow people to copy it. Like if you have a forum or group discussion, you obviously need to copy that message everywhere, at least to read it initially, but you also might want to just rely on the network effect. When new users join, they will get synced all the data from the other users. And when you do this setup here, in combined with the Blockcore DNS things we've been talking about, hopefully people will be able to be public hosts with their broadband at home. We don't need that much like centralized stable IP addresses at cloud providers.
That sounds amazing.
Yeah,
Well-
I agree. It sounds amazing. Yeah.
I'm sorry.
Yeah, I agree. What Sandra said, I mean, that's really the vision. That sounds amazing when we get there one day. Throw inside DID, where you'll be able to verify people's identities and control accessibility, or verify who can see what, and how you can issue multiple identities under the same root identity and so on.
Okay, well,
And this is basically the identity hub, or let's say data vault specification that the Decentralized Identity Foundation is working on. And it's also similar to the solid stuff that Berners-Lee is working on. Basically, either you run the software locally as a Docker container, or you install this on an exe file or whatever, or you just go on a cloud provider and you click next, next, next. You put in your credit card or send some crypto, and then you run sort of your data hub or data vault at a cloud provider if you want to.
okay.
And just one another note, as you mentioned, like right now in Blockcore Vault, I'm just doing a very basic storage functionality. I want to research more on IPFS. I've played around with IPFS a little bit, and I think I know that Daniel Butcher, I think that's his name, working for Block, he's using IPFS in his implementation of our data vault. And I think maybe we could find someone in the group here that want to do some more research and implement, as you mentioned, like file lab?
File-based. Yeah,
Yeah,
so
file-based.
I actually will take that task on. The first thing I'm going to implement for this as just a research project is I'm going to get something happening with file-based. I'm basically going to get a social media client reading and writing files from file-based. So that should be pretty straightforward. I'm pretty excited about doing it. So yeah, I'll take that on. And
Because we could, as a group, host Firebase or IPFS, like a cluster, and host the data as well.
Okay. Yes, I'm very, very interested in that. I will take that on. Yeah.
Okay, cool. Yeah. We do have a few powerful machines running around. That's the whole idea.
Okay. Okay, so we're basically moving through the list of 7 requirements here, and we're still on number 1. Does anyone have any more to say about distributed servers, quote unquote, and that sort of thing? Okay, moving on. Requirement number 2, functionality. Application logic must be deployable and upgradable across the decentralized network. Note, ask the X42 guys how they see this with their apps, with their dApps. X42 guys,
Yeah, I'll take this one.
Okay.
If you take a look at that decentralized DNS PDF documents I shared earlier last week, and if you take a look at the first part of that, basically this is in effect how instructions are going to be given. So it is a JSON payload. That JSON payload, in our case, is being stored in a MongoDB database and being broadcasted to the rest of the servers. And the way that is verified is by having the resulting hash being stored on the blockchain itself, so that it can be verified by the servers on the network. And basically, if you take a look at that JSON format, you'll see the first thing, the first property you see there is type. And over here we've got DNS. Action is add, and then we've got data. So that will be executed by the servers on the network once it has been verified on the blockchain.
Okay.
So in the exact same way, you could set the instruction to pull your latest image for your DApp from Docker Hub or whatever your Docker image repository is, and restart your application using the new image. Done.
Okay. Okay.
If I may, I think another important point to add to this is that depending on what application is hosted, it is up to the owner of that application to decide when to update that application. So essentially, if an application is being deployed and there is a decision to upgrade that application, I believe that there should be a function which allows that owner of the application to simply choose and press an upgrade button on the App Store, as we call them here.
Mm-hmm.
And in this way, they are able to control which version it's running. So we need to consider, when looking at any software application, the compatibilities between one version and the other.
Mm-hmm.
So of course, you want to allow people to upgrade in a way that is dangerous to the application. So it would basically bring it down. So I think there probably should be some feature for them to test the upgrade and actually deploy the upgrade.
Right.
Also consider, I would consider adding a security feature, something that so with Docker, there's a number of security risks that could potentially affect even the X server itself. So it could very well be adding an additional feature to maybe do some sanity checks, security checks, just scanning like the Docker image, like checking for outdated versions or things like that. You can use it public existing information as a good starting point for it.
Okay.
In fact, Docker Hub actually offers scanning of the containers as you upload them, and it can warn you of any known vulnerabilities.
Mm-hmm. Okay. Okay, that sounds pretty reasonable, pretty logical to me. Any other comments on that? Any other non-X42 ideas from anybody?
Well, just if we look at upgrading in decentralized,
Mm-hmm.
then there are some complexities. I'm just looking at Bitcoin and Bitcoin blockchains where there is some complexity there regarding mining. There is always the ability to maintain backward compatibility. So I think if we look at the decentralized world, in the terms of upgrading applications, you need to look at the terms soft fork and hard fork. I think I need to give it a bit more thought. But for example, if some application is upgraded, it needs to always be able to support backwards compatibility to clients who have not been upgraded yet on the network, right?
Yes.
In that sense.
Yeah.
And looking at upgrading, there's there's always you can never break compatibility.
Yes, I agree. Yeah.
Maintain decentralization.
Yeah, I think upgrades should contain new functionality or fixed bugs. Right? I mean, that's pretty much it. You shouldn't be changing anything that already exists. That would be dangerous.
You might break. I mean, it depends on how the decentralized network works, but you might break the part of it. Yeah.
Yeah, I think fortunately, I mean, one can make a really dumb client, right? It does not have to be a complex front-end application. It can be pretty simple. At least to start with, there's no reason why we can't make it as simple as possible just to test it. Okay. Any other comments? Moving on, data ownership. Each platform user must have complete control of their data.